Our planet, a vibrant blue marble suspended in the vast, silent expanse of space, seems to be a realm we have come to know intimately. We have charted its deepest oceans, scaled its highest peaks, and cataloged an astonishing diversity of life. Yet, for all our exploration and scientific prowess, we are only just beginning to comprehend the sheer scale and complexity of the cosmos that surrounds us. It is a universe of breathtaking beauty and profound mystery, a place where the familiar laws of physics are stretched to their limits and beyond. When we gaze upon a spiral galaxy, with its brilliant arms of stars and glowing gas, we are seeing only a fraction of its true self. What our eyes and instruments perceive is merely the luminous decoration on a far grander invisible structure. For decades, astronomers observed that galaxies were spinning far too quickly. According to our understanding of gravity, the stars at the outer edges should be flung off into the void. This mysterious substance has been named dark matter. It does not emit, absorb, or reflect any light. We know it is there only through its gravitational influence. For much of the 20th century, the greatest cosmological debate was about the ultimate fate of the universe. Would it collapse back on itself in a big crunch, or expand forever, slowly fading into a cold, dark emptiness? But in the late 1990s, observations of distant supernovae revealed something utterly astonishing, something that defied all expectations. The expansion of the universe is not slowing down. In fact, it is accelerating. In the quiet of an August night in 1977, the Big Ear radio telescope in Ohio was listening, as it always did, to the silent symphony of the cosmos. For 72 seconds, the telescope recorded a powerful narrowband radio signal emanating from the direction of the constellation Sagittarius. It was a signal so striking, so unlike any natural cosmic noise, that astronomer Jerry Amon, upon reviewing the data printout days later, circled it and wrote a single astonished word in the margin: "Wow!" Yet despite decades of searching, it has never been detected again. Numerous follow-up observations of the same patch of sky have yielded only silence. To explain this cosmic acceleration, scientists have proposed the existence of a new mysterious force, a kind of anti-gravity woven into the very fabric of space-time itself. They call it dark energy. It is thought to be a property of the vacuum of space, a constant, pervasive pressure that pushes everything apart. It is now believed to make up nearly 70% of the total energy density of the universe, yet we have no definitive explanation for what it is or why it exists. The universe, it seems, has a future more dramatic than we ever imagined, driven by a force we are only just beginning to contemplate. Despite all our advances, the universe still holds secrets beyond our understanding. These are not minor puzzles at the fringes of our knowledge, but fundamental questions that challenge our very perception of reality. They are whispers from the void, anomalies in our data, and paradoxes that confound the most brilliant minds of our time. From the unseen matter that sculpts the galaxies to the enigmatic energy that drives them apart, it beckons us to look deeper, to question our assumptions. Join me as we embark on a journey to the frontiers of human knowledge. We will venture into the darkness between the stars, peer into the heart of cosmic enigmas, and confront the most profound unsolved secrets of our universe. This is a story not of answers, but of the magnificent questions that drive our quest for understanding, reminding us that the greatest adventure of all is the pursuit of knowledge itself, in a cosmos that is far stranger and more wonderful than we can possibly imagine. The WOW signal remains the strongest candidate for an extraterrestrial transmission ever detected. Was it a fleeting message from a distant civilization? Or was it some unknown exotic natural phenomenon that we have yet to understand? The signal remains a singular event, an unexplained whisper from the void, that continues to haunt and inspire our search for others. Imagine for a moment the entire energy output of our sun, released not over a year or even a day, but in a flash lasting only a few milliseconds. Now, picture that flash actually originating from a galaxy billions of light years away. These are fast radio bursts, or FRBs. They are among the most energetic and perplexing phenomena in the universe. First discovered back in 2007, these incredibly brief but immensely powerful pulses of radio waves have been detected coming from all corners of the sky. In the cosmic menagerie, there is really no creature more strange or more terrifying than the black hole. Formed from the collapsed remnants of massive stars, they are points of infinite density where gravity is so strong that nothing, not even light, can escape. Their boundary, the point of no return, is known as the event horizon. To an outside observer, anything that crosses this threshold is lost forever, its information seemingly erased from the universe. This presents a profound conflict with the laws of quantum mechanics. Our galaxy, the Milky Way, contains hundreds of billions of stars, and our observable universe contains hundreds of billions of galaxies. With such an unfathomable number of potential homes for life, many of which are billions of years older than our own solar system, a simple yet profound question arises: where is everybody? This is the essence of the Fermi paradox, yet we find ourselves in a universe that appears eerily silent and, well, empty. We have detected no alien megastructures, no interstellar probes, no messages from the stars, just the quiet hum of natural cosmic processes. Is life, particularly intelligent life, exceptionally rare? Do civilizations inevitably destroy themselves before they can reach the stars? Or are they deliberately hiding from us, observing us from afar? The Great Silence is a haunting mystery. Our Milky Way galaxy is not stationary. Along with our local group of galaxies and countless others in our cosmic neighborhood, we are all being pulled, inexorably, in the same direction. We are moving at a staggering 2 million kilometers per hour towards a specific point in the sky. This is not random motion, it is actually a coherent flow, as if we are all caught in a vast invisible river current. The source of this immense gravitational pull has been dubbed the Great Attractor. The mystery of the Great Attractor is that, for a long time, we could not see what was pulling us. It lies in a region of the sky known as the zone of avoidance, an area obscured by the dense gas, dust and stars of our own Milky Way's disk. It's kind of like trying to see a distant mountain through a thick fog. While recent observations have revealed a massive supercluster of galaxies, the Laniakea supercluster, in that general direction, some astronomers believe it still doesn't fully account for the speed of our motion. The Great Attractor remains a shadowy gravitational anomaly, a reminder that even our galaxy's own path through the cosmos is dictated by structures of immense scale that lie hidden in the dark. But the mysteries only deepen when we ask what lies beyond the event horizon. Our current laws of physics honestly just break down completely at the central point, the singularity. Is it a gateway to another universe? A tear in the fabric of space-time? Or does something entirely new happen, governed by a theory of quantum gravity we have yet to discover? Black holes are not just cosmic vacuum cleaners, they are theoretical laboratories where the fundamental principles of general relativity and quantum mechanics collide. They are the ultimate unknowns, dark enigmas that guard the secrets of space, time, and the very nature of reality itself. The Big Bang Theory provides a remarkable account of our universe's origin from a hot, dense state some 13.8 billion years ago. However, the Standard Model presents a few puzzles. For instance, why is the universe so remarkably uniform on the largest scales? To solve this and other cosmological conundrums, the theory of cosmic inflation was proposed. It suggests that in the very first fraction of a second after the Big Bang, the universe underwent a period of mind-bogglingly rapid exponential expansion. While inflation is a cornerstone of modern cosmology and its predictions align beautifully with observations, the physical mechanism that drove it is still unknown. In the 1970s, humanity launched 2 probes, Pioneer 10 and 11, on a grand tour of the outer solar system and beyond. After completing their missions, they continued to coast into interstellar space, silent ambassadors from Earth. But as they journeyed farther from the sun, scientists noticed something strange. Both spacecraft were deviating from their predicted trajectories. After exhaustive analysis, the most likely cause was eventually identified. Heat radiating unevenly from the spacecraft's power sources was creating a minuscule but constant thrust. Of all the mysteries in the universe, perhaps the most personal and pervasive is that of time itself. We experience it as a constant forward-flowing river, carrying us from a fixed past to an uncertain future. Yet when we look at the fundamental laws of physics, we find they are almost entirely time-symmetric. The equations work just as well forwards as backwards. The most common explanation lies in the second law of thermodynamics. It states that entropy, disorder in a closed system, always increases. The universe began in a highly ordered, low-entropy state at the Big Bang. Its journey towards increasing disorder is what we perceive as the flow of time, but that pushes the question back: why was the universe so ordered to begin with? Is time a fundamental property of the cosmos, or is it an emergent phenomenon? We are creatures bound by time, yet the ultimate nature of what we are bound by remains one of science's deepest and most philosophical questions. We have journeyed through the cosmos, from the invisible matter that binds the galaxies to the mysterious energy that drives them apart. We have listened for whispers in the static of space and peered into the absolute darkness of a black hole. Each of these great, unsolved secrets serves as a powerful testament to the limits of our current understanding. They are not signs of failure, but markers on an endless frontier of discovery. The universe does not give up its secrets easily. It challenges us, teases us, and ultimately rewards our curiosity. These mysteries are the engines of science. They fuel our desire to build more powerful telescopes, devise more elegant theories, and push the boundaries of what is possible. The search for answers to questions about dark matter, the nature of time, or our place among the stars is a fundamentally human endeavor. It connects us to the generations of thinkers who gazed at the night sky and wondered just as we do. It is a quest that unites us in a shared sense of awe and humility before the vastness of it all. As we gaze into the cosmos, either through the lens of a mighty telescope or simply with our own eyes on a clear night, these mysteries remind us how much there is left to discover. The story of the universe is still being written, and we have the profound privilege of reading its earliest chapters, and perhaps, just perhaps, adding a line or two of our own. The journey is far from over. In many ways, it has only just begun.